In this video we are going to go through distance and midpoint in three-dimensional space. So if you have 2 points, say A and B, like that, with the coordinates x1, y1 and x2, y2, which is actually in coordinate plane, two-dimensional. Now let's remember the distance formula to be, well, this is exactly the same as magnitude and vectors, originated from the Pythagorean theorem. This will be the difference, the square of the difference in the x values, say x2 minus x1 squared, plus the difference of squares, square of differences, sorry, of y values. Of course, this will be in a square root. Now, in three-dimensional space, nothing changes in terms of mentality. Just that we will add the third coordinate z1 and z2 accordingly. Hence, we will calculate one more, say, square of differences, which is z2 minus z1 squared. So this also will be inside the, say, square root. So this is how we find the distance, and when it comes to midpoint in two-dimensional plane, it was kind of the average of the coordinates x1 plus x2 over 2 and y1 plus y2 over 2. Now we are going to add the third dimension, which is z1 plus z2 over 2. So let's go through an example. So in this problem it says safety regulations require airplanes to be at least a half a mile apart when in the sky. So they should be as far as half a mile apart from each other so that it will be safe. Two planes are flying above Cleveland with the coordinates given. This is the first coordinate for the first plane, and this is the coordinate for the second plane, where the coordinates are given in feet. This is also important because we are going to go through miles. Now in part A it says, are the two planes in violation of the safety regulations? So this means, is the distance between two planes smaller than half a mile or bigger than half a mile? We are going to determine this. If, in part B, a firework was launched and exploded directly in between the two planes, meaning in the midpoint of two planes, what are the coordinates of the firework explosion? So we are trying to find the midpoint here. Okay, let's start solving. So let's calculate the distance for part A. Now it will be 450 minus 300 squared as the first coordinate, plus minus 250 plus, sorry, minus 150 squared plus 28,000 feet minus 30,000 feet squared in square root. Now if we go through the calculations, it will be the square root of 150 squared plus minus 400 squared plus minus 2000 squared, and it will be 22,500 plus 160,000 plus 4 million in a square root, which will give you a total of 4,182,500, and which is approximately 2,045 feet. So the distance between those two planes is 2,045 feet. Now, how many feet is half a mile? Actually, half a mile is 2,640 feet. You see? And this means these two planes are violating the safety regulations because they are closer than the regulation tells us. So this means they are violating the regulation. Now, if a firework was launched and exploded directly in between the two planes, what are the coordinates of the firework explosion? So here we are going to try to find the midpoint of these two planes. So it will be like, say, 450 plus 300 divided by 2 minus 250 plus 150 divided by 2, and the z coordinates 28,000 plus 30,000 divided by 2. So let's try to calculate these coordinates. It will be 375 for x, minus 50 for y, and 29,000 for z. So this is our midpoint. This is where the firework should be exploded directly in between the two planes. So this is how we find the distance and the midpoint in three-dimensional space.